Credit classification for lenders, portfolio analysis using Python, Part 1 continued. C. Handling outliers and anomalies. Outliers and anomalies in the data can affect the performance of the credit classification model. Outliers are data points that are significantly different from the other data points in the dataset. Anomalies are extreme data points that are not consistent with the rest of the data. Outliers can be identified through visualizations such as box plots or scatter plots. Outliers can be dealt with through techniques such as Windsorization, trimmed mean, or quantile-based trimming. Anomalies can be detected through anomaly detection algorithms or manual inspection and removal. Identifying and visualizing outliers. Outliers are data points significantly different from the other observations in a dataset. They can arise due to errors in data collection, measurement, or recording, or they may represent unusual phenomena or events. Outliers can have a significant impact on statistical analysis and machine learning models, so it is important to identify and visualize them. Here are some methods for identifying and visualizing outliers. Box plots. Box plots are a graphical representation of the distribution of a dataset. They show the median, quartiles, and outliers of the data. Outliers are shown as points outside the whiskers of the box plot. Scatter plots. Scatter plots are used to visualize the relationship between two variables. Outliers can be identified as data points that fall far away from the other points on the scatter plot. Z-score. The Z-score measures how many standard deviations a data point is away from the mean of the data. Data points with a Z-score greater than 3 or less than -3 are considered outliers. Interquartile range, IQR. The IQR is the range between the first and third quartiles of a dataset. Data points that are more than 1.5 times the IQR away from the first or third quartile are considered outliers. Once outliers are identified, there are several ways to handle them, such as removing them from the dataset, transforming them, or treating them as a separate group in the analysis. However, the decision to handle outliers should be made carefully, as they may contain important information or insights about the data. Dealing with outliers. Outliers are data points that are significantly different from the other observations in a dataset and can adversely affect statistical analysis or machine learning models. Here are some methods for handling outliers. A. Windsorization. Windsorization is a method that replaces extreme values with less extreme values. Specifically, it replaces values above a certain threshold with the value at the threshold and values below a certain threshold with the value at the threshold. This method ensures that extreme values still have some influence on the analysis, but their impact is reduced. B. Trimmed mean. The trimmed mean is a measure of central tendency that excludes a certain percentage of the highest and lowest values in a dataset. For example, a 10% trimmed mean would exclude the top and bottom 10% of values in the dataset. This method reduces the influence of outliers on the mean, but still retains the majority of the data. C. Quantile-based trimming. Quantile-based trimming is a method that removes a certain percentage of data from the top and bottom of a dataset based on the quantiles. For example, a 5% quantile-based trim would remove the top and bottom 5% of values in the dataset. This method reduces the influence of outliers on the analysis while retaining the majority of the data. Addressing anomalies. Anomalies are data points that are significantly different from the other observations in a dataset and can arise due to errors in data collection, measurement, or recording, or they may represent unusual phenomena or events. Here are some methods for addressing anomalies. A. Anomaly detection algorithms. Anomaly detection algorithms are statistical or machine learning techniques that can identify and flag anomalous data points in a dataset. These algorithms work by comparing the observed data points to an expected distribution or pattern and detecting data points that deviate significantly from the norm. Some common anomaly detection algorithms include clustering-based methods, density-based methods, and statistical methods such as the Grubbs test, z-score, and Mahalanobis distance. B.
Manual inspection and removal.
Manual inspection and removal involve visually inspecting the data and identifying and removing data points that are deemed anomalous. This method is particularly useful when the data is difficult to model or when the anomalies represent a small percentage of the data. However, a manual inspection can be time-consuming and subjective, and may not be feasible for large datasets. Data collection and cleaning are essential steps in any data analysis process, and credit classification is no exception. Credit classification models require relevant, clean, and consistent data to perform accurately. To be continued. Thank you for watching.